Alright, today we will be talking about scientific notation. So, we are going to start by just changing the following into correct scientific notation. So first off, we just want to look, correct scientific notation means only one digit in front of the decimal point. So notice our current decimal point is here, so we need to move it 1, 2, 3, 4, 5, 6, 7, 8. So to be 1.5, and it's always times 10, and then to the 8th, we moved it 8 spots. However, notice this was a large number on this side. Now if we go to a decimal, which is a small number, it works the same way. Our decimal moves 1, 2, 3, 4, 5. So it'll be 2.5 times 10, but now it's to the negative fifth. So if you have a large number, your exponent is positive. If you have a small number, your exponent is going to be negative. So our next one, we've got negative 45,700. So our decimal place still is going to move. So we'll have negative 4.57 times 10, and we moved it 1, 2, 3, 4. And it was a large number, so positive 4. Over here, we want our decimal place to end up here. So we move it 1, 2. So we'll have 3.67 times 10 to the negative second. Now, notice all of these have scientific notation in them, but they're not correct, because if you look at that first number, all of them either have too many digits before the decimal, well, they all have too many digits. So in this first one, let's look at just this part. We can rewrite this as 2.73 times 10 to the first, because notice we only move it one spot, and then times 10 to the 7th. This is what we talked about yesterday. If you multiply bases, you can add exponents. So we'll have 2.73 times 10 to the 8th. On this second one, notice we need our decimal to be here. So looking at just this part, we can rewrite it as 3.4 times 10 to the 1, 2, 3, 4, 5, so negative fifth. Then we still have times our 10 cubed. Once again, we can add our exponents, and negative 5 plus 3 is negative 2. So we'll have 10 to the negative second. Same idea on this last one. We can change this to 8.75 times 10 squared, because it needs to move 1, 2, and then times 10 to the negative second. Add your exponents. You'll have times 10 to the 0, but anything to the 0 power is 1. So we're left with 8.75. So now we're going to change to standard notation, meaning we're going to get from scientific back to the numbers that you're used to. So once again, this fourth means we need to move our decimal 4 places. And remember, we need to end up with a larger number. So we're going to move it 4 places to the right. So we have our negative 9.6. We'll move it 1, 2, 3, 4. Which means we need to have 3 zeros here. So we'll have 96 with 3 zeros, so 96,000. On this second one, we have to the negative 8th power, which means we need to move our decimal place 8 positions, but this time we're going to the left because we need our answer to be a decimal. So we'll have 5.62, move it 8 spots, so 1, 2, 3, 4, 5, 6, 7, 8. So we'll have 1, 2, 3, 4, 5, zeros. 1, 2, 3, 4, 5, 6, 7, 5, 6, 2. And last but not least, we can use scientific notation to simplify computations that look really hard. They look like it would just take a lot of time. But we can actually simplify it with scientific notation. So let's start. This 320, we can rewrite it as 3.2 times 10 to the second. This 25,000 can be 2.5 times 10 to the 1, 2, 3, 4. And our denominator can be 4 times 10 to the 1, 2, 3, 4, 5, negative fifth because it's a decimal. Now, let's just look at our numbers or our coefficients that don't have our exponents. So we have 3.2 times 2.5, all of this divided by 4. But then with our exponents, remember if we multiply, we add our exponents, so it'll be times 10 to the 6th over 10 to the negative fifth. 3.2 times 2.5 is going to give us 8 over 4. And then we'll have times 10. Remember, subtract, so 6 minus a negative 5. 8 divided by 4 is 2 times 10. And we want to add our opposites here to the 11th. So 2 times 10 to the 11th. And if you wanted to write this back in standard notation, you could. And it would be 2 with a lot of zeros behind it. Now we've got one more to look at. Same idea here. Let's take this number into scientific notation first. So 1.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And our second one, we have times 5, times 10 to the 1, 2, 3, 4. Negative fourth, because remember it's a decimal. So now we'll just have this 1.2 times 5 times 10 to the 9th times 10 to the negative fourth. 1.2 times 5 will give us 6 times, and remember you add your exponents here, 10 to the 5th. Oops. That is all for scientific notation.